Today I have something very special for you. This is one of those videos that have been in the making for months. You've seen glimpses of it in the past, since quite a few previously published videos had hidden motives. I was exploring different tools and processes in search for the solution that we are going to explore today. So, what's the big thing, you might ask? Well, today we are going to build a fully operational internal developer platform, or IDP, that will be built in a way that can meet almost everyone's needs. How does that sound? Would you like to have an IDP? Would you like me to show you how to build it? Take a look at this. Click a button, fill in a few custom fields, wait for a few moments, and a new backend application was added to the IDP UI. But that's only the tip of the iceberg. A new repo was created with the code of a new application, a container image was built and pushed to the registry, updated manifests were pushed to a Git repo, the first release of the application is deployed, a database was created in my favorite hyperscaler, and I can see the outcome of all that back in the web UI. From there on, all that the developer needs to do is what developers do the best. Write code and push it to Git. New releases will be created and deployed automatically. What do you say to that? Shall we go back in time and build a similar IDP? Now, let me start with the warning. I will not go into the details about all the tools I will use in this video. I already explored most of them in the past, and I do have links in the description. Also, you should note that the tools used today are my choice, and you should be able to accomplish similar results with other tools. Think of this as an idea that happens to have a practical implementation which can be modified to use other tools. And here's another warning. This is not a video about the theory behind IDPs. I already explored that and offered a suggested architecture in that video. So, instead of a detailed explanation of the architecture of an IDP, I will only give you a quick rundown of what we're going to build. But before we do that, let me explain what the high-level goals are. I want to build an internal developer platform, an IDP, that should enable everyone to be autonomous. If someone needs a database, there should be a mechanism to get it, no matter whether that someone is a DBA or a Node.js developer. If someone needs to manage an application in Kubernetes, that someone should not have to spend years trying to understand how Kubernetes works. All that and many other goals should be accomplishable through different means. One should be able to define a simple manifest and push it to Git. Or that same person might prefer a graphical user interface and accomplish the same through a few clicks in a web UI. In other words, I want to enable everyone to do everything by consuming tailor-made services, and I want to enable experts to create such services. I want an IDP. So, what's the architecture of such an IDP? What is the high-level design? Thank you for asking. We will create a control plane that will be in charge of managing all the resources, no matter whether those are applications running in a Kubernetes cluster or elsewhere, or infrastructure or services in AWS, Azure, Google Cloud, or anywhere else. Further on, we'll create user-friendly interfaces that will enable everyone to interact with the control plane and manage resources at the right level of abstraction. The desired states will be stored in Git, so we'll have to add a GitOps tool into the mix. Its job will be to synchronize whatever we put in Git with the control plane cluster. Given that the state is inevitable, we'll have databases as well. Those databases will be managed by control plane, but we'll need a way to also manage schemas inside those databases. Further on, we will have some confidential information which we cannot store in Git for obvious reasons, so we'll have to add a way to manage secrets stored in a secret manager. To make things easy to observe and operate, we will not only allow people to push manifests directly to Git, but also create a user interface that will enable people to see what's running, as well as to execute processes that will create new resources and store them in Git. Finally, we need to be able to execute one-shot actions like creation of new repositories based on templates, building images with new releases, changes to manifests, and so on and so forth. To do those one-shot actions, we'll need pipelines. There will be a few other types of tools we'll have to use, but those mentioned so far are the most important ones. You and everyone else in your company will be able to interact with the system either by making changes to Git repos or through the UI or GUI or GUI, Graphical User Interface. Anyways, that's the high-level architecture of the IDP we are going to build today. So let's start cracking. I already set up a cluster and installed a few tools. I won't go through what I did so far because I want to focus on the important parts and avoid making this video last for hours. You will find the link to the gist with the setup and all the commands I'll execute from now on, so go and check it out if you want to follow along or reproduce what I did at your own pace. With the setup out of the way, let's talk about control planes. It's simple. We need a single entry point, a single API with which we can interact and which in turn will manage resources no matter where they are. Today, I will use Crossplane as the control plane, and there's a video about that as well. It's already preloaded with a few providers which enable me to manage not only Kubernetes, but also AWS, Google Cloud, Azure, or other types of resources. So here it goes. Let's take a look at what I have so far. kubectl get CRDs. Now, based on this, we can create CRs that would create deployments, services, manage databases in a hyperscaler, clusters, and so on and so forth. That, however, is not the right level. An application can easily consist of dozens of resources. Infrastructure can be even more complicated. Those are low-level resources. Those are not right levels of abstraction for people who are not specialized in Kubernetes or AWS or GCP and so on and so forth. We need something more user-friendly, yet something tailor-made for our needs. We'll figure out that next. For now, what matters is that we got a control plane, but we just started. There's a long way to go. We need to start thinking about user-friendly interfaces. We need to figure out what is the right level of abstractions for the users of the platform we're building. Do people care about subnets? No? Hide it. Do people care about database storage? No? Hide it. Do people care whether it is Postgres or MySQL? Yes? Expose it. What is the right level of abstraction depends on the users of the platform and will differ from one organization to another. Heck, it might even differ from one team to another. It's up to you to discover how to best serve your customers and there everyone else in your organization. Now, since you already introduced Crossplane as the control plane, it makes sense to use it to create those user-friendly interfaces, those abstractions, and we are going to use Crossplane compositions for that. So let's take a look at a few that I already have in this control plane by executing kubectl get CRDs, and I'm going to grab the stuff that contains DevOps Toolkit series. Now, here we can see custom-made CRDs that are not part of Crossplane, but made by me. Two of those are abstractions meant to simplify management of different kinds of applications, and the other two are for managing databases or SQLs. Since the abstractions are extensions of Kubernetes API, they are discoverable. You already saw that we can list them with kubectl get CRDs. We can also retrieve the schema through kubectl explain, like kubectl explain upclaims DevOps Toolkit series.com recursive. User interfaces can do the same. For example, I can visit the marketplace where that composition was published and find out what it is, and so on and so forth. The point is that anyone and anything can discover what something is instead of hard coding that something. Now, I will not go into more details about Crossplane compositions. Check out that video if you're not familiar with them. Now, as a user of the platform, I can define something as simple as what's in app YAML. So let's take a look by executing cat crossplane app YAML. Now, behind the scenes, that claim will expand into quite a few Kubernetes resources and quite a few AWS, Google Cloud, or Azure resources required to run both the application and the database. I could, and I repeat, I could execute something like kubectl apply and let the control plane know what I want, but there is a huge but. I will not do that. That would not be a good idea. We should not interact with the cluster, with the control plane directly. Instead, we should put the desired state into Git and let GitOps tools synchronize it with the cluster. That way, we have a more secure system, no direct access to it, and we always know what should be the desired state. So far, we got the control plane and user-friendly interfaces, and there's still a lot missing, but we're getting there. Changing the state of resources by communicating with the control plane directly should be illegal. That leads to questions like who changed what and when and why. Instead, we should push the desired state into Git, maybe do a review if it's a pull request, and once it gets to the mainline, let GitOps tools ensure that the desired state is synchronized with the control plane, which in turn will convert it into the actual state. Today we'll use Argo CD to do that synchronization, even though Flux would do more or less the same job. If you're not familiar with Argo CD, please watch those videos and I'll keep explaining it in more detail. Instead, let's install Argo CD by executing Helm upgrade and so on and so forth. Next, I'll open Argo CD UI and login. And next, we'll create a project and the apps, one for infrastructure and the other for applications running in production. And we'll do that by executing kubectl apply for project YAML and another kubectl apply for apps YAML. Now that the apps are in Argo CD, I must say that for most people, this is not the UI they should be using. We'll get there, I promise. For now, what matters is that we can push the desired state into Git and let Argo CD synchronize it with control plane. We're still missing a few components. We have a database, and databases need schemas that differ from one application to another. We need to figure out how to manage schemas, preferably as part of application definitions and using GitOps. There are many ways to manage schemas, but only a few that enable us to specify them in a way that fits into GitOps model. The complication is that GitOps tools work only with Kubernetes resources. And that means that schemas should be defined as Kubernetes resources as well. So we need to extend Kubernetes API with custom resource definitions or CRDs that will enable us to define schemas as Kubernetes resources. Today, we'll use SchemaHero for that. Now, there is no time to explain how it works, so watch that video. I already have the manifests for SchemaHero itself, and all there is to do is move them into the infra directory with cp argo cd SchemaHero YAML goes to infra, and push them to Git with git add, git commit, git push, and a few moments later, here we go. Argo CD synchronized it and we can move on. From now on, we can define schemas as Kubernetes resources and let Argo CD synchronize them with the control plane. Are we done now? At least with the database? No. We still need to figure out how to instruct Crossplane to create a database with a specific password. Such password cannot be stored in YAML and pushed to a Git repository. So we'll use a secrets manager provided by us by whichever hyperscaler you're using. The app composition already expects a secret to be retrieved from a secrets management system using external secrets. That part is already done. It's already part of the composition. However, we still need to install external secrets and configure it to use secrets management system provided by the hyperscaler we're using. We cannot store unencrypted secrets in Git. I hope you understand why we cannot do that, right? We have only two options in front of us. We can encrypt secrets and then push them to Git, or we can keep them in a secret store and pull them into the cluster, not to the cluster. We'll do the latter using external secrets. And as you already know, we won't go into details about external secrets because I already did that. Watch that video. Instead, we'll just push the manifest with external secrets into Git and let Argo CD synchronize it with the control plane. So I'm going to copy the manifest with CP, and then I'm going to git add and git commit and git push. Now, let's wait for a few moments for Argo CD to sync, and voila, it's there. Now, to actually pull secrets, we need to provide external secrets credentials to the secrets manager of choice. I have a manifest for that as well, so let me push it to Git and let Argo CD do its magic. And that means I'm going to copy it into infra directory, and I'm going to execute git add and commit and push, and we still need to instruct external secrets which secret to pull from the secret store. That will be the secret that contains the password for the database we will create soon. Now, to make things easier, Crossplane composition we'll use already contains the logic to pull a specific secret from a secret store, so there is nothing else for us to do, at least when secrets are concerned. Now we have everything in place, except that some people might prefer using a graphical user interface instead of writing YAML files and doing stuff from a terminal. We need a UI sitting on top of everything we built so far. We're almost there. Now we need a graphical user interface that will provide a catalog of services people can use, as well as a way to perform certain actions. Specifically, we need a way to initialize a process that will create a new repository for an application, add sample code, provide manifests for the database if the application is stateful, create CI/CD pipelines that will build container images and push changes of the manifests to Git, and so on and so forth. We'll use port for that, and if you're not familiar with it, please watch that video since I'm not going to explain how it works. So let's open port in a browser. Now we'll need new environments, so let me add a blueprint for that. So I'm going to output environment blueprint, copy the output, and then back in port UI, add it as a custom blueprint. We'll also need a blueprint for applications backed by a database. So let me output backend up blueprint JSON, copy the output, go back to port UI, add it as a custom blueprint, and that's about it. We'll also need to instruct port how to ingest data from the control plane, and to do that, we'll need port credentials. So I'm going to get credentials, copy client ID, put it to a variable client ID, do the same thing with client secret, and then use those to construct Helm values or set Helm values that are required before I output the whole manifest and push it to Git with git add commit push. Now, keep in mind that what I just did is terrible. It's horrible. I pushed port credentials to Git. Do not do that. Do not push any credentials to Git. I did it only because this is a demo and I'm too lazy. Finally, we'll create an action that will execute automation that will create everything an application needs. You know what that is. A Git repo with the source code and manifests and Docker file and pipelines and so on and so forth. So let me output backend up action JSON, copy the output, go back to port UI and paste the output, create that action. We could now execute an action that will create a backend application with a database. However, actions in port are only triggers of some actions executed somewhere else. We still need to create real actions that will create a repository for the application with the source code, application definitions, and pipelines. Finally, we need pipelines. You might call them CI or CI/CD. This is the last piece of the puzzle, and we'll use GitHub Actions, even though any other pipeline solution should work just fine. If you're not familiar with GitHub Actions, there's a video for that as well. There's a video for everything in this channel. Now, this repository already contains a pipeline that will create everything an application needs. So let me output it to the screen. That's create up db YAML. And first of all, we have inputs that will be propagated from port to GitHub Actions workflow. Further on, we are checking out the code. We are creating a new repository by executing a simple script. We are creating Argo CD manifests so that new application is included in synchronization. And finally, we are pushing the changes back to that repo. Now, the first of those two scripts is relatively simple. It creates the repo and it executes devstream, which in turn converts a template repository into the final repo. It's a nice little tool. I mean, devstream is a nice little tool, and I did not cover it yet in my videos, but if you let me know in the comments, I certainly can do that in the future. And the second script is create Argo CD app sh. That script creates Argo CD manifest for the new application, and it's even simpler than the previous one. All it does is copy a template file and executes JQ commands to replace placeholders with actual values. That's it. We created a control plane and user-friendly interfaces. We enabled synchronization from Git to the control plane. We have a way to manage database schemas and secrets. We got a graphical user interface, and we can execute one-shot actions with pipelines. We have a fully operational IDP, at least when backend applications with databases are concerned. All that is left is to see it in action. Otherwise, you'll complain that I'm just showing you random stuff without showing any of it in action. Now, let me open Service Hub in port and execute the process by clicking the Create Backend App with DB action. I'm going to set repository name to IDP demo app. I could change image repository or anything else. There are default values that work for me, not necessarily for you. And I'm going to set host to something, ahmed.com, and click the execute button. And that's it. That's all there is to it. That single action is all that one would need to do to create everything required to start working on a new backend application with the database running in AWS or Azure or Google Cloud. Now, if I wait and wait for a bit and go back to the backend apps import, you can see that they're there. If you like to go and communicate directly with the control plane, I can execute something like kubectl namespace production, get application claims, and you can see that they're there as well. Or if you're interested specifically to the resources created for the application itself, we can see them with kubectl namespaces production, get all ingresses and secrets and whatever else. Now, what matters is that it takes a bit of time to create all the resources in AWS as well. And I can see the status of those resources by executing kubectl get managed. It takes a while with Crossplane to process all the possible resources. There are many of them, but eventually you will see all the resources that are managed by Crossplane, which includes both those running in the cluster itself and those that are in AWS. And with enough time, everything will be created, everything will be up and running, and I can go back and display all the resources in production, including ingresses and secrets, and you can see that the application is finally running. It took a while because it needed a secret from the database, and that secret that contains authentication couldn't be created until the database, RDS database, was created, and so on and so forth. Anyways, the first time it takes a few minutes because it takes a bit of time until hyperscaler resources are up and running, but eventually everything is peachy. And if you don't believe me, we can go back to my AWS console and you can see that there's the database, there's RDS. So let me walk you quickly through the process. What happened when I executed that port action? First of all, I executed the action in port, which triggered GitHub Actions. And GitHub Actions created a new Git repository based on a template using devstream. When that repo was created, GitHub Action build was triggered in that build, and it built a new image. It pushed it to Docker Hub, and it created a custom as overlay patch that contains the tag of the newly built image. Further on, it created a new Argo CD application and pushed it to the management repo, IDP demo in this case. That Argo CD application points to the application repo, and it deployed the resources defined in the application repository. Those resources are Upclaim, which is Crossplane composition, which created all Kubernetes resources required for the application, as well as created all managed databases, not the databases in the hyperscaler, in this case, AWS. And it pulled the secret using external secrets manifest wrapped in that composition as well from the hyperscaler secret manager. The second resource in the app repo was SchemaHero manifest that created a database schema inside that database. And once the composite claim was deployed to the cluster, Port ingested it and created a new entity called backend app and associated it with the production environment. All that happened by executing a single action in Port. From now on, all you have to do is push changes to the application repository and process will repeat itself except the part that creates a new repository. And that will be happening over and over and over again. What is missing from this setup? Well, many things are missing. I did not add pull requests in preview environments. I did not add security beyond external secrets. I did not add infrastructure management beyond databases. I did not add, well, many things. And whether I will add more or not depends on you. Please let me know in the comments whether a solution like this makes sense and whether you'd like me to add more stuff to it. I feel that this is a good start of something potentially amazing. This could, if I continue, turn into an all-encompassing IDP for everything. That's it for now. Thank you for watching. See you next time. Cheers.